Hello everybody, my name is Subrajit Sahu, Assistant Professor in Narasimha Engineering College. So in this class I'm going to discuss the bimetallic strip or bimetallic thermometers. Already in the last video, the temperature measurement topic, I gave some idea about why the temperature measurement is necessary. What are the several places, several situations where temperature measurement is really required frequently at a particular interval, and we also understood what is the importance of the measurement of temperatures. So based on that, we started discussion on the first temperature measuring instrument, that is bimetallic thermometers. Also in the last class I told the working principle of the bimetallic thermometers. Just started today, I'm going to continue the same bimetallic strip here. In this video, I will tell the working principles, advantages, disadvantages, application of the bimetallic strip. We will slowly observe here. And before that, what yesterday class or last class, what I told, or the important terminology here I'm going to use, that is alpha, right? Alpha. What is this alpha? This alpha is called thermal coefficient. Okay, thermal coefficient of linear expansion. The thermal coefficient of linear expansion. Sir, what is the meaning? No. I told, if there is a metal, then deformation will be happen without application load also. Without application, if load is not there, by the help of temperature changes, it is going to differ something. Deformation will be happen. Change in dimension will be happen. If it is delta L and original length is L, then there is a beautiful definition or mathematical expression will come, delta L equal to alpha into L into delta T. What is delta L? Change in length. What is alpha? Alpha is the thermal coefficient of linear expansion. What is the L, sir? L is the original length of the object, right? And what is delta T? Change in temperatures, right? Change in temperatures. We can write T2 minus T1 or T1 minus T2 based on the sign convention you need to take care. So this is the expression here. Sir, what is alpha? Important term. All these things we know. Delta L we know, delta T we know. This one is maybe new for you. Thermal coefficient of linear expansion. Sir, what is the meaning? Meaning I will tell you simply. Simple meaning is there. Observe carefully. What is the meaning, sir? Here, suppose there is a metal is there, a bar is there. Suppose a bar is there, length is L. Okay, initial length is L. Okay, initial length is L. Okay. Now at this moment, the temperature is T1, suppose, equal to how much? 30 degrees Celsius. 30 degrees Celsius. Now this is the situation. I measured the length of the bar is L at 30 degrees Celsius. Now what I will do, sir, I will increase the temperature. To 31 degrees Celsius. Okay, initially 30 degree. Now increase the temperature 31 degrees Celsius. If I will increase the temperature 1 degree Celsius, I will record once again what is the length. Definitely there is a small change in length we are going to get. Small change. If the material is very much sensitive to temperature, definitely a small change in temperature, so change in length we are going to get here. So what is the thermal coefficient of linear expansion means? It is the amount of deformation. We can say it is a properties. It is a properties of metal where the amount of deformations, how much amount of deformations is happening per unit or per 1 degree Celsius rise in temperature. Okay, how much deformation is happening when I'm increasing the temperature of a particular body or particular bar or particular column. How much degrees? 1 degree, unit degree Celsius. Then this concept is called linear expansion. Shortly we are calling linear expansion, or thermal coefficient of linear expansion, or thermal coefficient of linear expansion. So beautiful definitions. What is the definition means? It is the property of a metal where we are checking how much deformation is happening for 1 degree Celsius rise in temperatures, right? So the expression we have in the previously I have written delta L equal to L into alpha into delta T. Sir, what is the alpha value here? Delta L by L by delta T, right? Alpha, linear coefficient of thermal expansion formula is this one. Alpha is equal to delta. So what is this delta L by L? Strain, right? Deformation means strain. So how much deformation here happening? How much deformation is happening? Why when the delta T is 1 degree, only 1 degree, then it is called alpha. How much deformation is happening when with respect to temperature 1 degree rise or delta T is 1 degree, then that particular relation is called linear coefficient of linear expansion or thermal coefficient of linear expansion. So what is the unit? Very simple. Unit is here from this formula we can determine. Here delta L by L unit will be cancelled. So 1 by, and delta T temperature unit is Kelvin or Celsius, degree Celsius or Kelvin, right? So unit is 1 by degree Kelvin or 1 by degree Celsius, or we can write alpha unit is K to the power -1 or degree Celsius to the power -1. This is the important point about this linear coefficient of thermal expansion. I hope this is understood to all of you. Now coming to this bimetallic strip. What is happening in the bimetallic strip? I told as the name indicates, we can take two metals, right? Two metals. Sir, if we will take two metals, sir, what is the thickness of the metal? Very simple, I will take. Observe. This is one metal, and this is the side view, right? And this is another metal. Okay, another metal. Okay, now this is the front view, sorry, not side view, front view. Metal is actually like this. Metal will be looks like, if I will see from the front side, sorry, top side, it will looks like this. Right. This is one metal, and this is another metal, right? This is the side view, this is the front view. Now two metals I'll take. Sir, what is the dimension of that bimetallic strip? Remember, the thickness of each metal should be the thickness. The thickness each metal should be 1 mm to 2 mm variation. 1 mm to 2 mm, right? Thickness of this metal we have to take here. And we have to rigidly fix these two metals. Sir, how to rigidly fix? Several methods are there. This two metallic strip, since the thickness is 1 mm to 2 mm, we can call it as a strip. Strip thickness generally very less. Okay, the sheet just like some sheets, right? Iron sheets, galvanized iron sheets, right? Where through which we are making the tray in the workshop, right? That kind of thickness. Okay. Anyway, so now how to join? How to join the two metals? We can join by welding. We can do welding. We can do brazing. Okay, or we can do soldering also, or we can do riveting also. All are permanent joint, right? All are permanent joint. So any one method we will take to make a join between two metals, right? This is the welding. Suppose I did like this, I have to join it. After that, I have to make one end fix. This end is fix. This end is fix, right? This end is fixed and this end is free end. This is fixed end and this is free end. Okay, free end. And in the free end, what I will do, sir? I will attach one pointers. I will attach one pointer like this. I will attach one pointer. This is also rigidly fixed. And then here one calibrated temperature measuring scale I will install here. Like this. Temperature measuring scale I will be installed. Sir, observe carefully. Here, when when the temperature is at normal conditions, that means atmospheric temperature, then the condition of the bimetallic strip is straight condition. It is straight. Okay, it is straight. Sir, you didn't tell what is the two metals we are taking. Two dissimilar metals. This is one metal, this is one metal. Suppose this metal is A and this metal should be B. Dissimilar metal. What are those metals? I will tell after this construction and working discussions. I will tell what are those metals, suitable metals we can use for constructing a bimetallic strip, right? So now this is the simple constructions. Now coming to the working, how it is working. Now when three condition I will tell. Three condition I will tell. When the temperature is a normal temperature is normal. Okay, normal. It is straight. The metallic strip will be straight condition. It will be straight. No variations, nothing will be. What is the temperature reading? That is only. Now suppose temperature increase. Temperature is increase. Then what will be happen, sir? If temperature will be increased, out of A and B, definitely one metal having more alpha value and another metal having less alpha value comparison to another metal. So one metal having more alpha value and another metal having less alpha value. So if temperature will be rise, what will be happen? So which metal having more alpha value, that will be try to deform very fast, and which metal having lower alpha value, that will be try to deform late. That means since both are combining, rigidly combining, so they are in between them, somebody will try to go forward and somebody will be restrict the motions. Like this situation will be happen. Okay na? Because alpha value is more means it will be, suppose A alpha value is more, B alpha value is less. Suppose you assume A alpha value is more and B alpha value is less. So in this case, A metal will be try to move very fast, and B metal what will do, since it alpha value is less, it will try to restrict the A motion. So by this kind of combinations, what will be the results? Result is the metal is going to bend here. The bimetallic strip is going to bend here. Okay, na? The bimetallic strip is going to bend here like this. It will be bent like this. It will bend. Right. If it will be bent here, the pointer which was earlier in this position, it will come to in this positions. It will come to in this position, right? This is one situation when temperature rises. When the temperature decreases below the normal temperature, what will be happen? If the normal temperature will be, the temperature will decreases below the normal temperature, then immediately opposite effect will be happen. Opposite effect in the sense, the bimetallic strip will be bent in these directions, right? It will bend in this direction. If in this direction, then immediately the pointer will be moves from this position to this position. Okay, this position. Then I can here from these three different positions, I can measure what is the temperature available here. So this is the total working and construction of a bimetallic strip. Sir, what are the metal? What is the metal for A? What is the metal for B? We can choose several metals, but based on the properties which is very much essential for the temperature measurement, or which are very much suitable for the temperature measurement, we can take those type of materials. What are those materials, sir? Number one is we can take steel. Okay, we can take steel. Number two, we can take copper, and number three, we can take brass. Number four, also we can take iron. Like this, 3-4 metals are available. We can take different metal having different alpha value. So steel alpha value is what? For the steel alpha value is 1 minute. For the steel alpha value is alpha value is 12 into 10 to the power minus 6 Kelvin to the power minus 1. Similarly, for the copper, alpha value is copper, for the copper 16 point something, 16.5 suppose, into 10 to the power minus 6 Kelvin to the power minus 1. And for brass, it is around 18 or 17.8 into 10 to the power minus 6 Kelvin to the minus 1. So among these three, brass having more alpha value and steel having less alpha value. Sir, we can take the combinations brass with copper, or copper with steel, or brass with steel. We can take the combination for this bimetallic strip. We cannot check, or we cannot take brass with brass. It is not possible. Okay? It will not possible, because no reading we are going to see here. So we should select such materials, one metal having more alpha value, another metal having less alpha value, then only the bimetallic strip will be work here, right? So this is the working and principle of construction working of a bimetallic thermometer. Several methods I told. Now I will tell you the advantages and disadvantages of this one. What is the advantages, sir? Very simple. Advantages is what, sir? First advantages here, this kind of instrument, bimetallic strip instrument for temperature measurement, not required any electric power source or any power source. Electric power source is not required. Okay, electric power source is not required. Not required. NR, not required, right? Number two is what? Since that it is metallic strip and we are connecting them by the help of riveting welding, the design is robust, right? The design is robust. Robust means very strong. It is very strong, right? Number three is what? Less cost. Is less cost. Okay, less cost. Number four, anybody can operate it. Little bit knowledge the person having can also, anybody can operate it. No special people or special trained person is required to operate, right? Anybody can operate it. So like this, 4 advantages I listed here. Sir, is there any disadvantages? Yes, disadvantages also there. What is the disadvantages? Observe. What is the disadvantages here? Sir, disadvantages, first one is what? 1 minute. First one is disadvantages. What is the disadvantage, sir? First one is accuracy issue. Okay, accuracy issue will come, because every time the metal will be bent either from top direction, bottom direction, so right direction, left direction. So every time temperature, with respect to temperature change, the metal is going to be bent always. So after certain period of use, suppose 2 year I used, 3 year I used, then in that metal permanent deformation will be formations. Permanent, slowly, permanent deformation will be formations. So in that reason, what is the result in the earlier stage, in the new stage it was giving, after 2 years same result may not be give. So accuracy issue we are going to find in this device. Also accuracy issue. Accuracy we cannot get proper accuracy. Number two is what? Number 2 point is what here? Okay, na? It cannot measure. It cannot measure very less temperature. Very less temperatures. Okay, na? Very less temperatures. Suppose I want to measure very less temperatures. We cannot measure by these mechanical instruments. So this is one of the disadvantages here. Very less temperature also we cannot measure by this bimetallic strip, right? Bimetallic. Sorry, right. So what are the several applications, right? I will tell the several applications. What are the several applications? Very simple. Here one diagram is there in front of you. From the beginning onwards, I have kept ready this diagram. Observe this diagram. What is the diagram, sir? This bimetallic strip application is what? It can be act as a switch. Okay, application is what? Switch. So see, so when this is bimetallic strip, this one is the bimetallic strip, this one. So when the temperature changes will be happen, what will be happen? It is bend. When it is bend, it is disconnect the circuit. It is disconnect the circuit. Suppose this is the switch. Disconnect the switch. So suppose in case of iron, you imagine. Suppose after 5 minutes, excess heat will be happen. Automatically, power will be disconnect. Why? How, sir? When the temperature will be raised, the bimetallic strip is bent and it raise the connection. It raise the connection. Disconnect the connection. So that's why current connection will be cut, and after some times again it will become normalized. Once again it will be normalized, again it is going to touch here. Again it is going to touch here. So again current supply will be started, again heating will be started. So this process is repeatedly happening when you are using the iron, right? This is one practical application. So I told, observe here carefully. Here also same diagrams. Okay, here also same diagram, just like switch, electrical switch. Sir, we can use in a refrigerator also. Refrigerator also, this bimetallic strip is also using, because when a particular range of cooling effect will be produced, automatically the compressor will be stop. I mean electrical current will be stop. Sir, electrical current stop and on by the help of a switch only, right? So this is, and by bimetallic strip we can prepare a automatic switch based on the temperature changes. It will be operate automatically, right? This is one application, refrigerators. Where is the, we can find the application in so many industrial sectors, industries. There's a for temperature measurement we are using. Sir, these are the applications. Here several variety of bimetallic strips are available. This is one more, what, spiral shape. This is spiral shape bimetallic strip, and this one is helical shape bimetallic strip. And what we discussed, this one is, okay, rectangular shape. This is rectangular shape like this, right? Like this rectangular shape bimetallic strip. So I hope this topic, nothing is there, this much only. I hope this one very clear to all of you. And if any doubt, let me know where is your doubt, then I will explain once again, no problem. So it is a good point to stop here. So I will conclude here. In the next video, I will take a new topic on this temperature measurement. Till then, take care and bye.